Hi, my name is Marcos. I'm doing my PAF 301 Applied Statistics presentation on Goodman and Kruskal's gamma. Gamma is defined as the measure designed for ordinal by ordinal tables that may also be used when one of the two variables is a nominal dichotomy, which we may handle as if it were ordinal. Gamma emulates the net proportions of concordant pairs of observations, those consistent with the hypothesis as compared with all pairs of observations. Gamma can be found in our chapter 11 of our text on pages 367 to 371. The gamma formula is P subscript S minus P subscript D over or divided by P subscript S plus P subscript D. That's equals gamma. Okay. Even though we use the formula for gamma, in order to find the P subscript, we use the algorithm, a set of instructions that applies to tables of any size. As we use the algorithm to generate a series of subtables, to do this, we begin in the upper left-hand corner or cell or the box. We take note that the cell entry to create a subtable containing everything that is both below and then to the right, and then we'll go below and then to the left for the second part of the subscript B. Yes. We ignore all margins and totals in the table, such as these. We ignore those. We also skip any cell or box whose entry is 0, as well as any box or cell that has nothing below or to the right of it. Okay? So, we start with P subscript S, okay, and we're going to find P subscript S and P subscript D. So we start with the top left corner, and then we go down, diagonal, and down. So we have the 136 where we start here, put it right there, and you have the 38, and you go with the 34 right there, and we write it in just as it is. So basically, you go from here, down, and then here. So you're basically taking this box here and you're placing it here. Then you go to over here with 28, which is there. Then once again, diagonal and then down. So that's what we have there, the 20 and the 102. So then we go to the second row, which is 20 here for neutral, okay? And you do 20, and then you do 34. So you go diagonal, 34, and then the 102, which is that right there, okay? So then we do the 38, which is, once again, second row over here and down to the right, which is the 102, okay? Now with the subscript B, okay, we're doing the next right here. Start this line, not here, but we start here now. So we go 38, which we put here, 38, okay? Then we go down into the left this time. So we're going diagonal down there. So then we put the 8 right here, okay? So then we also, once again, we're on the second row here, 20. What do we do? Down to the left. So you got your 34, and then to the left, which is 8. Okay, we have to put it in there the same way it's in the table. So you go 8, 34. Okay? So then now we're, once again, oh, nothing here. So nothing, oh, we gotta go all the way back to the top now. So we go here, boom, to the left. So there's 20. And then what's to the bottom, or I'm sorry, below it, boom, there's the 8. Okay? So now we're doing, once again, 14, down and to the left, diagonal. So what do? We got the 38 to the left, 34. Once again, we put it the same as in the box. So we basically take this here, 28, 38, 34, 28, 38, 34. So we go boom, and we did that right there. Okay? So now what we do is, we have to add up all of these. So you go 38 plus 20 plus, okay, so you're adding up 38 plus 20 plus 34 plus 102, then you multiply by 136. And you get 26,384. You 28 times 102 plus 20, okay, which is 3,416. 20 times multiplied by 34 plus 102, which is 2,720. 38 times 102, 3,876. Now that's P subscript S, okay? So that's what we did was S. Okay. Then what we're going to do is we're going to take all of these and we're going to add them all together. Okay. And that would give our P subscript S. I'm not going to do that just yet. We're going to go over here. 38 times 8, 304. 20 multiplied by 8 plus 34 is your 840. 28 multiplied by 20 plus 8, which is 28. 28 times 28, 784. 14, now you have to add all these. Okay, so 20 plus 38 plus 8 plus 34 multiplied by 14 is your 1400. So we're going to add 304 plus 840 plus 784 plus 1400. Okay, so, and that was P subscript B. Okay, now we have P subscript S, which was there at 36,396. Now what we do is we minus, subtract from P subscript D. We add all those, we get 3,328. Okay? So now that was P subscript S, the top portion. Now we go to the bottom, which is P subscript S plus P subscript D. 36,396, which we already have. Now it's plus, instead of minus, the same P subscript D, which is 3,328. So we do the minus plus, so the subtraction gives us 33,068. That's what the subtraction gives us. Now the addition gives us 39,724. Now what we do is we have to divide 33,068 by 39,724. What that gives us is gamma, or Y. Okay, and that gives us 0.83244.30627. And we can just shorten that to 0.83244, or we can just go 0.83. And that gives us our gamma for the Walmart customer satisfaction and the length of wait time in that customer service line, which was satisfied, neutral, dissatisfied. And we had 136 satisfied, we had 20 neutral, and 8 dissatisfied for 12 minutes or less. 12 to 24 minutes was 28 satisfied, 38 neutral, and 34 dissatisfied. Now, if you waited 25 minutes or more, you were 14 of the 400 were satisfied. So, and the 20 were neutral, but 102 were dissatisfied if they waited 25 minutes or more. Which, if we add up all of these, 178, 78, 144, comes up to 400. So we did a poll of 400 Walmart employees. Okay, and this was the gamma that we found, which was the strength in which, if you take 0 to 1, and you got your 0.5. Okay, so now you have 0.883. Okay, so that was my I had pondered the relationship between the customer service wait time and the overall customer satisfaction during the Walmart Christmas season. I hypothesized that people with a shorter length of wait time would be happier customers and have a Merry Christmas. And that's obvious right here, where 0.83, so